Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at gradient, midpoint, and length of a line segment. Note, when you're finding the length of a line segment, you're really finding the distance between 2 points. And we can use Pythagoras to help us find the distance between 2 points. Now remember that the gradient is the slope of the line. It's sort of a measure of how steep a line is. The number for the gradient doesn't mean a lot by itself, but allows you to compare lines. So numbers with a gradient of higher magnitude, they are steeper. And if they have a lower magnitude for their gradient, then they are flatter. All right, let's look at calculating the gradient, midpoint, and length of the line segment joining these 2 points. Some people are visual learners. They like to see it visually, so you can draw up a Cartesian plane if you'd like to see this. Now, let's not be super accurate with it. Let's not rule out all the way up to 9. That'll probably take longer than the actual question. We can just plot the points thereabouts. So -5, 9 is about over there, and then we'll plot 3, -6, which is around about there. So the question is asking us to take this line segment here and calculate the gradient, midpoint, and length of it. So note, line segment has a start and an end, doesn't go forever. That's what distinguishes it from a line. So let's start here with the gradient. So to know the gradient, we want to know how we get from this point to this point. Now my advice is always start at the point on the left. So to get from this point where we start to this point where we end, we're actually going to go across and down. These will be at right angles because x and y axes are at right angles. So we've gone across from -5 to 3, so we've gone 8 along the x-axis, and to go from 9 to -6, we've gone down 15. Now because we've gone down, I'm going to write it as a negative. So m, little m, which means the gradient, is the rise over the run. It tells you how far you've gone up or down divided by how far you've gone across. It's the change in y over change in x. So the rise here is -15. Negative rise because we went down. And the run here is +8. So if you want to write that as a decimal, it's -1.875. That's the gradient. So it's negative because we went right and then down. Negative gradients always happen when the line segment is leaning to the left. Now, if you start with the leftmost point, like I said, then the run will always be positive. So gradient -1.875, it means each time we go across 1 to the right, we go down by 1.875. All right, let's look now at the midpoint. So we can use these numbers here to help us find the midpoint. What we're after is we're after the point along the line segment that's halfway. So if we've gone across 8, halfway will be across 4. So if we go across 4, the x-coordinate here will be -1. -5 plus 4 is -1. So I'll use capital M for the midpoint. Its x-coordinate's -1. Now, what about the y-coordinate? Well, we've gone down 15. So halfway along here is down by 7.5, because that's half of 15. So we started with a y-coordinate of 9. 9 minus 7.5 is 1.5. So that will be the y-coordinate. And of course, it is okay if a point has a coordinate that's not a whole number. So that's the midpoint. That's the point halfway along the line segment. All right, let's now calculate the length of this line segment. So in doing that, we're calculating the distance between this point and this point. And note, when you have 2 points in a 2D plane like this, the shortest distance between them is always a straight line that joins them. Okay, so the distance between these 2 points, the length of the line segment, we can use Pythagoras. We have a right-angled triangle. To find the hypotenuse of a right-angled triangle, it's just the square root of shorter side squared plus shorter side squared, and you get 17 units. We just write U because we don't know whether it's centimeters, meters, or whatever. So there, we're done. All right, let's now look at calculating gradient, distance, and midpoint using formula. So if you're somebody who doesn't like the visual method that I just showed you, you can use these formula. This for gradient, this for midpoint, and this for distance. Now all of these involve x1s and y2s and all that. So read this as x coordinate of the first point is x1, x2 is x coordinate of the second point. Similarly, y1 is y coordinate of the first point, y coordinate of the second point. So when you have your 2 points here, it doesn't matter which you call point 1 and which you call point 2, as long as they're together. If I call negative 4x1, then 5 has to be y1. And if x2 is 2, y2 has to be the y coordinate that goes with it. Okay, so let's calculate the gradient of the line segment joining these 2 points. This time we're using the formula. So the formula for gradient is y2 minus y1 over x2 minus x1. So negative 1 subtract 5 is negative 6. 2 subtract negative 4 is positive 6. The gradient here is negative 1. So because the gradient's negative, this line segment would lean to the left. All right, let's now calculate the midpoint, which I'll use a capital M. So the midpoint's nice and easy. To find the x coordinate of the midpoint, you just add up the x coordinate divided by 2. To find the y coordinate of the midpoint, you just add up the 2 y coordinates and divide by 2. So halfway between negative 4 and 2 is negative 1. Halfway between 5 and negative 1 is positive 2. So the midpoint is negative 1, 2, and we are done. All right, let's now do D for distance, or the length of this line segment. So using Pythagoras, it's just the square root of. So x2 minus x1, 2 minus 4 squared, and then plus y2 minus y1 all squared. So if you do that, you get the square root of 72 is the exact answer. As a decimal, it's about 8.5 units. All right, let's now look at examples where we're using the distance gradient or midpoint to find one of the points. So in this example, we're told we have this line segment. We're given one endpoint and the midpoint, and we have to find the other endpoint. So what we have is this. We have A, which is 9, negative 9. And we have some point B at the end of our line segment, and we don't yet know what it is. We need to find its x and y value. Now, halfway between them, the midpoint is 2, negative 3. So we need to find this value and this value. Now, because this is the midpoint, 2 is going to be halfway between the two x values. So from 9 to 2, we've subtracted 7, so we're just going to subtract 7 again. 2 subtract 7 is negative 5. The x coordinate's negative 5 because 2 is halfway between 9 and negative 5. We're now going to do the same for the y values. To go from negative 9 to negative 3, we add 6. So then we add 6 again, and this time we get positive 3. So that's the answer, because negative 3 is halfway between negative 9 and positive 3. We are done. These are the coordinates of B. All right, this next question tells us the distance between 34k and 4639 is 37 units. Calculate two possible values of k. So we're going to use the idea behind the distance formula, or the length of a line segment. So you may wish to draw this, you may not. Let's look at what it would look like if I drew this. So again, I'm not going to be super accurate and rule up my Cartesian plane, so it's 4639. So 4639 is going to be about there. So 34k, this tells us that the x-coordinate is 34. So the x-coordinate of 34 will be about here. The point is going to be somewhere on this line. We're saying the x-coordinate is 34, and we have to find what the y value will be. So let's just put the point here for argument's sake. So what we're told is the distance between these 2 points is 37. Now we know that the run, we going from this point to this point, we're going across by 12. It's 46 minus 34. So what then would this distance be? Well, if I just call that x, I can easily figure that out using Pythagoras. See, x, because it's the shorter side of a right-angled triangle, we subtract, and I'm just going to get 35. The distance here has to be 35. So What does that mean? It means k is either 35 more than that or 35 less than that. So k is going to be 39 plus 35, which is equal to 74, or it's going to be 39 minus 35, which is equal to 4. So for each of these cases, the rise will be 35 or negative 35, and so the distance will be 37. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.